Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, as we are continuing with the physical properties sessions, today let's discuss about the density and the gradation of density with respect to groups and periods in modern periodic table. So first find out what is density. Friends, density is defined as a mass per unit volume of a substance. Well, it is a physical property of matter. A physical property can be measured without changing the chemical identity of the substance, that is, liquid, gas, and solids are the physical states. Since pure substance have unique density value, measuring the density of the substance can help identify that substance. Well, density can be determined by dividing mass of the substance by its volume, and the units of the density in terms of physical properties, physical states of matter, where solid is gram per cubic centimeter, density of liquid is gram per milliliter, density of gas is gram per liter. In other words, density can also be defined as the density is the measures of compactness in the molecular arrangement in any substance, which determines how heavy or light any substance is. Well, these are the two examples where we can see that the density also depends upon the arrangement or the compactness of the substance. Those we the molecules in which the arrangement is very compact have a higher density with respect to the substance with the very low compactness of the molecule will be having a low density. Well, again, let's understand in the 3D format. Higher density substances are those which have the particles very packed together due to the intermolecular forces are very high, and the spaces between the molecules is not very much, or they are very close just due to the intermolecular forces. So these kinds of substance, whether it is a solid, liquid or gas, have the higher density. More of the solid substance have the higher density comparing to liquid and gas. Those substances which have lower density will be having a very loosely packed molecule together. That is, the intermolecular forces between the molecule is very less, and there is more space between the individual molecules between them. For example, we can say that the wood is more like having a low density than an iron nail. So let's take the whole conclusion regarding the physical state. We have three states: gas, liquid and solid. You can see the differences between the density of all these three physical states. So the density moves towards the solid from gas, that is from lighter gas having a lighter density, then we have a liquid, and then yes, it is a solid which have the higher density. So now this we can understand the density of the substance will depend upon the packedness of the, that is the packedness arrangement of the molecules of the substance. Secondly, the mass of the atom and the size of each atom. So by this picture you can see here, we can conclude that the solids will be having a higher density than liquid, and lesser density substance will be the gaseous state substances. So the amount of mass in a given space depend upon the density of the matter. So now let's take the example of many substances together and see the difference between the density of these substances. Well, you can see the higher density substance will go downwards in this beaker. That is, they will sink more, then the lighter one will float more. So the highest density in this examples is the iron bolt. Then we can see the honey. The density of the honey is higher than the corn syrup, or you can say the corn syrup density is higher than the popcorn kernel or milk. So higher you will go in this picture, you'll get the idea of the lesser density substances. So you can see this, the ping pong ball having a very less density than the iron bolt. So friends, now let's come up to the arrangement or the variation of the density in the modern periodic table with respect to groups and periods. Though friends, there is no such trend of increasing or decreasing of density in the modern periodic table, but yes, we can conclude by the physical states of matter that among gaseous and liquid non-metals, as the atomic number increases, the London dispersion force, which will be increasing with the number of electrons, which result in higher polarity or intermolecular force attraction. Therefore, we can say that density generally increases as the atomic number increases. Well, friends, we know that in the modern periodic table, we always talk about the metals, non-metals, and metalloids. Well, we know that the metals with the solid state having a higher density, as the majority of the metals have the higher density than the majority of non-metals, as the higher density of most of metals is due to the tightly packed crystalline structure of their metallic structure, and the strength of the metallic bond of different metal reaches a maximum around the center of the transition metal series. So those elements have the larger amount of delocalized electrons in the tight binding type of metallic bond will be having the higher density. So we can also call that the density of the element also depends on such like atomic radii, nuclear charge, number of bonding orbitals, overlapping of orbital energies or crystal forms, which are also involved when we talk about the density of any element. As we are discussing the trend of the density with respect to groups and periods, we'll always say that when we talk about group, though there is no trend, but yes, according to the arrangement of these elements, we given a bit idea that the density tends to increase as you go down the group. But yes, there are the variation in each and every group. Well, if, for example, if we talk about the first group, which have the lithium, sodium, potassium, rubidium, cesium, and francium, the density keeps on increasing from lithium to Na, that is sodium. Then the density decreases in potassium, then start increasing as we go downwards, as the density depends on basically two factors. First, how many atoms are packed in a given volume. Second, the volume depends on the atomic radii. So as you go down the group, the atomic radii increases, and so the volume of atom increases as well, which means that particular number of sodium atom will weight more than the same number of lithium atom. So here we can say in particular group that yes, when we go downwards, there are the variation, but yes, the trends first keeps on increasing, then decrease, and then start increasing. Similarly, when we talk about the variation in the periods, that is the left to right, when we move from left to right in the period, the density tends to increase from left to right to middle and then decrease from there to the right. As starting from the hydrogen and going across, the density slowly climbs up while it reaches to the lighter gases where it significantly declines or decreases. For example, nitrogen, oxygen, fluorine, neon, etc. And the only time the number falls going across in which they hit the certain gases. That is, it firstly keeps on increasing, then it start decreasing and then start decreasing altogether. So by this, we'll conclude the session that there is certainly no specific trend in periodic table when we talk about the variation of density, as the density of element can only be determined by dividing mass of the substance by its volume. Also, the density depends upon three factors, that is a mass of an atom, the packing arrangement of the particular element or the substance, and the size of each atom. For example, gold in the middle of the transition metal has a density of 19.3 grams per cubic meter. That is the only real way of determining the density is to either divide it by mass, by volume, or calculate to the individual level of the substances. Yes, there is no trend as because it also has to do with the state of matter. That is, metal will tend to have a higher density because they are of positive charge, and also all the radioactive elements are also have the higher density. So you cannot learn anything about the variation of density when you look to the modern periodic table. So friends, here I conclude all these points. So when we talk about the density, we should only calculate the density by dividing the mass by volume. We can all of the individual elements. So friends, here I end up with my session. In next session, we shall learn about the variation of melting and boiling point in the modern periodic table. Thank you. Thank you for watching Edupedia World videos.